Hey guys, so it is Friday finally, woohoo! All right, well, it's Thursday right now actually, but I know that you're going to see this and it's going to be Friday, so woohoo! All right, so 2.4, day 2, rates of change and tangent lines. So we're going to start off with example 1. It says, well, first of all, before we get into example 1, anytime we're talking about a rate of change, you've heard this before, we're talking about the slope of a line. Okay, so it says Joe weighed 130 pounds after 3 weeks of protein shakes and 150 pounds after 5 weeks of protein shakes. What was his average weight gain per week during that time period? Okay, so we need to find a rate of change. When we're finding an average weight gain, we're finding the rate that he has changed in his weight. Rate of change. So you've seen this before. It's basically the change in the y values over the change in the x values. That little triangle represents the word change. It's a delta symbol. Okay? So it said after 3 weeks of protein shakes, he weighed 150 pounds. So we'll let x be the time in weeks. And we'll let y be how many pounds he weighs. So for the first coordinate, after 3 weeks, he weighed 150 pounds. Then after 5 weeks, he weighed after 3 weeks, he weighed 130 pounds. Looking ahead. And then 150 pounds after 5 weeks. So 150. My bad. Okay. So we have 2 coordinates there. And we can easily find the slope between those 2 points. It's our good old-fashioned slope formula, y2 minus y1 over x2 minus x1. Okay, so we always just label our points. It doesn't matter which one goes where. x1, y1, x2, y2. Okay, so when I plug that in, I'll have y2 minus y1, so 150 minus 130, all over x2 minus x1, so 5 minus 3, which equals 150 minus 30 is 20. 5 minus 3 is 2. 20 divided by 2 is 10. So he is gaining 10 pounds per week. You always got to make sure that you include the units, especially when we're dealing with a word problem like this. Okay, units are huge. You all have taken chemistry, I'm sure, so huge. Physics, units are huge. Got to make sure that you include them when they're a part of a problem. Okay? All right, so let's talk about that average rate of change. When we're finding an average rate of change in calculus, we're basically looking at the slope of a secant line. A secant line is a line that kind of goes through a graph, like the one we see below in this graph. This would be a secant line, okay? It's where we find the average rate of change over an interval, the interval AB in this case. So what does this mean? It just means that we're using the same old formula. It just makes it look a little more fancy because we're in calculus now, but it's the same math. So we're still using y2 minus y1 over x2 minus x1. That's what this means. Okay, so our interval, the x's are always our interval because that's our domain. So that AB it's an x1, x2. Get so used to writing x's and y's, but that's an x1 and an x2. Okay. So that's why we see b minus a, x2 minus x1. Okay, so example 2, it says use the graph to determine the average rate of change in the population of fruit flies per day between day 23 and day 45. Keep track of your units. So again, it has these words, average rate of change. So we're basically finding the slope of that secant line. So here's our graph, and we see these 2 points. There's at day 23, and here's at day 45. We just have to find the slope between those 2 points on that secant line. Okay, so super easy, right? So we're just finding slope. So let's see, y2 minus y1. So we'll go 340 minus 150 all over 45 minus 23. 340 minus 150, that is 190. 45 minus 23 is 22. 190 over 22, I'm going to get a decimal. You're going to get approximately 8.6. But now I have to keep track of my units. And remember, this was the number of flies per day. So it's 8.6 flies per, the little bar there means per day. 8.6 flies per day. Oh, I hate fruit flies. They annoy. All right. Example 3. Grass clippings are placed in a bin where they decompose. For 0 less than or equal to t less than or equal to 30, the amount of grass clippings remaining in the bin is modeled by A of t equals 6.687 times 0.931 to the t power, where A of t is measured in pounds and t is measured in days. There are units. Letter A, it says find the average rate of change of A of t over the interval 0 less than or equal to t less than or equal to 30. Indicate units of measure. So include your units in the answer is pretty much what that's saying. Okay. All right. So it said that we're finding the average rate of change. So we are finding the slope. Okay. So what we're going to do is we're going to take this function, because we don't know what it looks like. It's got all these weird decimals and stuff. And we're going to take it to the GC, our graphing calculator. So I'm putting that in your notes so that you know that we are going to a graphing calculator. Okay. So I'm turning on my graphing calculator, and I'm also going to clear the memory. Okay. Because I want to make sure that we're on the same page. So let me double check. Oh, no, I didn't do it. I'm going to change my window back to what it is originally, what it is normally, so that you can see when I have to make an adjustment. Anyways, how to set that up. Okay, so when we write this, obviously in the graphing calculator, we're using X's and Y's. So I'm hitting the Y equals button, and I'm going to type in 6.687 and then parentheses 0.931, close the parentheses, and then raise it. So I'm going to hit that up arrow button to the X power, because I don't have T's in here. We got to use an X. Okay. And then I'm going to hit graph. And I see it coming along. It's definitely exponential decay. All right, so now I want to use that interval it gave me. It said to find the average rate of change over this interval. So remember, when they give us an interval, like in the little box up here, I have to follow it. So I need to find the coordinates at those endpoints. So basically what these coordinates give, what these values are, they're the X values. So on one of my points, the X value is 0. On the other point, the X value is 30. So remember how we can figure out the Y value that goes with those X values in the graphing calculator? We learned it at the very beginning. So I need to hit second and then calculate and then hit 1 for value and see it's blinking. Now I could type in 0 for X and I'm going to hit enter. And it's that point right there that's blinking. And the Y value is 6.687. Okay, now let's try the 30. So I'm just going to type in 30 Hit enter, and it says this. That doesn't mean I did anything wrong. It just means I have to change my window. So hit window if that happens. Oops. Quit and then hit window. Notice my window is only from an X value from -10 to +10. Well, I need to get a value for a X that has a +30. So I need to change my graph. So I can keep the -10, that's not a problem, but I need, since I need 30, I want higher than 30 on the graph, so I'll put 40. 40, 50, whatever, as long as it's a little bit bigger, okay? And then I'm gonna hit graph. See how it changed what we're looking at? It's still the same graph though, it's just we moved over a little bit to the right. And now when I hit second calculate, 1 for value, and I can type in a 30 for X, now it gives me a value at 0.78292979. So I'm going to round that to the thousandths, so 0.783. Okay. So now I have those 2 points there. So remember, T stood for the days, and A of T is measured in pounds. So the X values are the number of days, so 0 days to 30 days, and the Y values are the number of pounds. So this is pounds and this is pounds. So 6.687 pounds to 0.783 pounds. Okay, so again, we need to find the slope. We need to find the change in pounds over the change in days, the slope. So we'll have y2 minus y1, so 0.783 minus 6.687 all over 30 minus 0. If I go to my regular part of the calculator, I could type in 0.783 minus 6.687. I get this number. Divide by 30 minus 0 is just 30, so divide by 30, and I get negative 0.1968. So negative 0.1968, and my units are in pounds per day. So it's decreasing by 0.1968 pounds per day. Okay. So when it tells you to find average rate of change, it's talking about finding the slope between 2 points on a line that is going through the graph. Okay. So you're just finding the average. So that's why we just take the endpoints. Okay. All right. Turn the page. Sorry, my printer prints it out bad. It's because I bought cheap ink for it and I didn't get the brand name. It was a lot cheaper though. Gotta save money somewhere, right? Okay, anyways. Instantaneous rate of change is slightly different. We're still talking about slope, but this is slope of the tangent line. And we've already learned from the previous lesson that when we're finding the rate of the tangent line, we're finding the derivative. And that's where we use this little formula to find the derivative. The limit as h approaches 0 of f of x plus h minus f of x all over h. So the following are going to be, or are equivalent, not going to be, they are equivalent. The slope of y equals f of x at x equals a. The slope of the tangent to y equals f of x at x equals a. The instantaneous rate of change of f of x with respect to x at x equals a. And the limit as h approaches 0 of f of a plus h minus f of a all over h. Okay, so instead of x's, we're using a's, but it's pretty much the same thing. These are all equivalent. Okay, so when we say rate of change, we mean instantaneous rate of change. How is that different from what we did before? Well, what one word changes it all, guys? Average. Average. When you see average rate of change, you're just finding the slope between those 2 points. When it says rate of change or just instantaneous rate of change or an instant rate of change, then we're talking about the derivative, okay? All right, so we have this graph, and we're going to have a secant line going through this graph. So this is our secant line. We'll also have a tangent line on this graph. So we'll have a tangent to this point. Oh, I want to use a different color. I want to make it green. So I'll have a tangent line right here. Okay, so we have a point of intersection here. We have a point of intersection with the secant line there. Okay. So let's say we have an x value at that first point, and we'll call it x. And then the next x value at the next crossing will be, we'll call it x plus h. So if we were to plug that into the function, the output would be the y value. So if we plug in x, the output would be f of x, plugging in x into the function. If I plug in x plus h into the function, the output value would be f of x plus h, because we're plugging in x plus h into the function. Okay, this is just in general, okay? So when we are finding an average rate of change, we are finding the slope between those 2 points of the secant line. So that means we would have an x value that's x, a y value that's f of x here, and then over here we would have an x value of x plus h and a y value of f of x plus h, and we would find the slope between those 2 points. If we're finding average rate of change, the slope between 2 points on a secant line crossing through that graph. If we are finding a rate of change or an instantaneous rate of change, then we are looking at the derivative. We're looking at the slope of the tangent line at that specific point. So if we are finding the slope of a tangent line, that means we're taking a derivative, so we're using the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, that would be the derivative at that point. So the derivative at that point. Sorry if I sound like all tired, because I am tired. Hasn't been a bad week. I've just been exhausted. I twisted my ankle yesterday. My son left an inflatable airplane on the floor, and I got up early to go work out because I couldn't sleep because my son had kept me up all night because he had growing pains and he was crying all night. He's 7, by the way. And I was doing high knees, and I didn't know that inflatable airplane was right behind me, and I just moved a little bit backwards and stepped on it, twisted my ankle, fell to the ground, was in a lot of pain, and I'm doing a lot better today, but it still hurts. It's still pretty tender, so yeah. Anyways, so that's the difference between the secant line versus the tangent line, and when we're finding an average rate of change, slope between those 2 points, and just a rate of change or an instantaneous rate of change, and that is the derivative, at that specific point, that tangent line at that point. Sorry, I'm losing my voice. I've been talking too much. All right, example 4. We're going to find the instantaneous rate of change. So it actually says the word instantaneous. So that means we're finding the derivative of this function at that specific x value of 2. So let's start it off, just like the other day's homework. The limit as h approaches 0 of, so remember I have to plug in an x plus h, so 2 times quantity x plus h squared minus 1, and then I have to subtract the original function, so subtract 2x squared minus 1, all over h. Okay, and then let's clean this up. Remember, x plus h quantity squared, when we multiply it out, is x squared plus 2xh plus h squared. Okay, So when I rewrite this, I'll have the limit as h approaches 0. I'm going to go ahead and distribute that 2 that's out front to everything there. So that will give me a 2x squared plus 2 times 2 is 4xh plus 2h squared, and then minus 1. And then I have to distribute that negative in front of the parentheses here. So that would be a minus 2x squared. And then negative times negative is positive, so plus 1 all over h. Okay. All right, so we can cancel some things. I have a 2x squared and a negative 2x squared. They gone. I have a negative 1 and a positive 1. They gone. And so now all I have left is 4xh plus 2h squared over h. Remember, all or nothing. They all have an h that I can cancel out. So I can cancel out this one, and one of those. Okay, so let's rewrite this. What do we have left? The limit as h approaches 0 of, I have a 4x left plus I have a 2h left, and that's it. Okay, now we could plug in that 0 for h. So that's going to give us 4x plus 2 times 0. Well, 2 times 0 is 0, so they gone. That one's gone completely. And then we just have 4x. So that's the slope formula. Now we need to figure out, okay, well, what is it when x equals 2? So that's where we plug in that value of 2 for x. So 4 times 2 equals 8. So the instantaneous rate of change is 8. I don't know the units, though, because this one didn't have units to go with it. So you just put 8. All right, number 5. A rock breaks loose from the top of a tall cliff. One of my sister's worst nightmares, because we go running on the trail all the time, and she's afraid that a rock is going to fall on her head and she's going to die. But anyways, what is its average speed during the first 2 seconds of fall if an object dropped from rest will fall freely, y equals 16t squared feet in the first t seconds? Okay, has anyone spotted what the key word was? It is right here. Average. So that tells us that we are looking at a secant line crossing through the graph of whatever this is, and we're going to find the slope between those 2 points. And they gave us the 2 points in here. We just have to pick them out. Okay? So we know that it is dropped from rest. So that tells me that one of the points is 0, 0. Okay, we're dropped from rest. Okay, so it hasn't moved yet. Hasn't fallen, hasn't moved. Okay, there's no feet per second because it hasn't gone anywhere yet. Then it says during the first 2 seconds of fall, it'll fall freely, y equals 16t squared feet in the first t seconds. So if we know that it has fallen 2 seconds, we can plug in a 2 for t. A t for 2, 2 for t. Me for you, and you for me. I'm pretty sure that's a Sesame Street thing that's stuck in my head. I grew up with Sesame Street, so if that happens, I'm sorry. All right, so 2 squared is 4. 16 times 4 is 64. Okay, so the next point will be, well, when the time is 2 seconds, it will have gone 64 feet. Falling 64 feet. It will have fallen. Okay, so what we got to do now is a slope formula. We get to use slope, like what you did back in Algebra 1, Math 1. So remember, the slope formula is y2 minus y1 over x2 minus x1. And let's just start plugging it in. So y2 would be 64 minus y1 is 0 over x2 is 2 minus x1 is 0. 64 minus 0 is 64. 2 minus 0 is 2. 64 divided by 2 is 32. Yeah, 64 divided by 2 is 32. I was like, wait, why did it rhyme? But it didn't. All right, so 32. And remember, it's falling feet per second. So it has fallen 32 feet per second. That is his average speed falling down. The average speed of this rock falling off the cliff. Okay. So that's the first page. Second, well, this is technically the third page if you didn't print front to back. Example 6 is what we're on now, okay? And it has to do still with the same problem. So it's still the, y equals 16t squared, okay? Still the same problem. It says find the speed of the rock at the instant t equals, and instead of 2, let's make it t equals 3, because we already did t equals 2. So let's do 2 equals 3 in the above example. Okay, so because it says instant, we're not finding average rate of change. We're finding instantaneous rate of change. So AKA the derivative, all right? So that means we have to use the derivative little formula. So let's get going. We have the limit as h approaches 0. This is our function. So we're just, instead of, we have to plug in a t plus h, like if it were an x, and we plug in an x plus h. So we'll keep the t. So 16 times t plus h, quantity squared, minus the original function, which is just 16t squared, all over h. Okay. So remember, t plus h quantity squared, when you multiply that out, will be t squared plus 2th plus h squared. And then you'll have to multiply 16 times all of those terms because it's in front of the parentheses there. So we'll have the limit as h approaches 0 of, let's see, 16t squared. 16 times 2 is 32, so 32th plus 16h squared. And then I have minus 16t squared all over h. Okay. All right, we can get a little cancel happy, so let's do that next. We have a 16t squared and a negative 16t squared. They gone. That's all that canceled. But we do have now, since we just have the 32th plus 16h squared all over h, they all have an h. So remember, all or nothing, we can cancel out that h. Here, here, and one of these. Okay, so let's rewrite what we've got now. We have the limit as h approaches 0 of, I have a 32t plus 16h, and that's it. So now I could plug in that 0 for the h, okay, and I will get 32t, because 16 times 0 is just 0, so it's just going to be 32t. So this is my slope formula, but it's at a t value of 3. So now I've got to plug in the 3 for t. So 32 times 3 is 96. So remember, this was about the rock falling in feet per second. So at that instant, at t equals 3 seconds, the rock is exactly falling 96 feet per second. So it's falling pretty quick. Gravity. And then we're not doing example 7 and 8. All right, so your homework is going to look like this for, oh, whoops. That's going to be next. Oh, where did I put the, well, I was going to show you what the worksheet looked like, and I don't know where I put it. I must have dropped it. But it'll be posted after this assignment posting, and then you'll have 2.4 day 3 also today, and that's coming up next. All right, bye.